So, example problem 2.2. During a storm, rain comes straight down with a velocity of negative 15 meters per second and hits the roof of a car perpendicularly. The mass of rain per second that strikes the car roof is 0.6 kg per second. Assuming that the rain comes to rest upon striking the car, find the average force exerted by the rain on the roof. So, let us assume that this is the roof of the car and this is the raindrop. So, this has a mass which is equal to 0.06 kilogram per second. So, let's just write that down. And its initial velocity, v sub I, is equal to negative 15 meters per second. So, this is negative since it is directed downward. And for the final velocity v sub F, that is equal to 0 meters per second because it will come to rest upon striking the roof of the car. So, these are the only known, and we are asked to find the average force exerted by the rain on the roof. So, for the solution, we will use the equation that impulse J is equal to the force, the average force times the time elapsed t, and this is equal to the change in momentum. So, notice that the mass is given in terms of kilogram per second. So, we can omit this term. So, we can write F is equal to the mass, which is equal to 0.06 kilogram per second times the final velocity, which is 0, minus again 0.06 kilogram per second times negative 15 meters per second. So, we will get multiplying, we will get positive 0.9 kilogram meter per second squared, that is equal to Newton. So, this one is the force exerted by the roof to the raindrop. So, what we are asked to find is the force exerted by the rain on the roof. So, by action-reaction, the force F exerted by the rain on the roof is equal to negative 0.9 Newton. So, this is the final answer.